Okay, we are going to finish up the second part of 3.4 notes. So we left off at number 3 here where it says the graph shows the position S of t of a particle moving along the horizontal coordinate axis. So the graph shown to you is actually the position function. It shows you where the object is as you are tracking its movement throughout this time of 7 seconds, right? So then the question is, when is the particle moving to the left? When is the particle moving to the right? When is the particle standing still? So it's a little bit tough to see this because it just shows you where the position is. It doesn't show you the direction. So what you need to infer from the graph is the velocity of the particle to know when it is moving to the left or moving to the right. So we know that velocity, excuse me, we know that velocity is the first derivative of the function, right, of the position function. So it is the slope of the function. Right. So then you need to figure out what indicates direction, right? What does it mean when a particle is moving to the left? What does it mean when a particle is moving to the right? So the particle moves to the left when your velocity is negative. It moves to the right when your velocity is positive. Okay, so it means that, again, the velocity has a sign that attaches with it, so it tells you the direction in which you are going. So positive velocity means you're moving to the right, meaning you're moving away from your origin, and a negative velocity means you're moving left, you're coming back to where you started from. So the left and right means it's a positive, negative, right? When is the particle standing still? When v of t is equal to 0. So there's no velocity at that point. Okay, so then let's take a quick look at what is happening in this picture here. Initially, your velocity, your slope. So we're looking at the slope of this graph. This graph is the position. So we got to look at the slope of the graph and look at whether it is increasing, decreasing, positive, negative, or standing still. So the slope actually starts off with 0 because it's a flat slope, 0 slope. Then the slope is negative heading down, so that means we're going backwards. We're heading to the left. Then my slope is positive, it's going up. That means we're going to the right. And then standing still again. Okay, so it's 0, it's negative, it's positive, and it's 0 again. Okay, then let's use that to answer our question. When is the particle moving to the left? Well, it's moving to the left when it's negative slope, so it's from 2 to 4. So between 2 to 4. Now, no equal to, because at those points, you're changing direction. So at those points, you're neither moving left nor are you moving right. You don't include those endpoints. Okay? When is the particle moving right? Well, it's moving right in this little segment here. That's going from 4 seconds to 6 seconds. So between 4 seconds to 6 seconds. When is the particle standing still? The particle is standing still here from 0 to 2. Once again, in this little segment here, from 6 seconds to 7 seconds. And that's it. All right, so again, keep in mind, positive slope means you're moving right, negative slope means you're moving left, and 0 slope means you are standing still. Okay. Number 4 is looking for marginal cost. Now, I'm not going to be claiming that I'm an expert at connecting calculus to econ, so you might want to talk to your econ teacher and see if they can give you a better explanation of marginal cost. But I would try my best. This is the calculus version of it, and this is the calculus connection. All right. So the first thing it's asking you is this is the this is the function that mimics the dollar's cost of producing X number of washing machines. So this is the formula given to us. Part A is asking you to find the average cost of producing 100 washing machines. Okay, so what does average cost mean? Well, the keyword is average. Anytime you see that, so average cost, average speed, average whatever, it is really asking you for the slope, meaning it's asking you for one endpoint minus the initial over the endpoint, the end x point to the initial x point. So it's looking for y2 minus y1 over x2 minus x1. So in this case, my y2 is going to be the cost of 100 machines minus the cost of 0 machines all over 100 machines minus 0 machines. So y2 minus y1 over x2 minus x1. All right, so first let's calculate what's the cost of 100 machines. It is 2,000 plus 10,000 minus 0.1 times 10,000. So that's 12,000 minus 1,000. So that gives me 11,000 for 100 machines. So 11,000 minus, what's the cost of 0 machines? The cost of 0 machine is just 2,000. So 2,000 all over 100. So it's 9,000 over 100. So the average cost is roughly $90 per machine. Okay, so that's my answer to part A. Part B then asks you to find the marginal cost when 100 machines are produced. So in calculus terms, what is marginal cost? Marginal cost is the instantaneous cost, right? So it is the is C prime. So marginal cost and that's where I'm saying you might want to talk to your econ teacher and figure out what is marginal cost. So I looked it up. Marginal cost is the cost, let me see, so it's the change in total cost when the quantity produced changes by 1 unit. I think I need a little more explanation than that. So right now my calculus connection is that it is the derivative of the original cost, right? So again, more explanation. This is where you branch out and talk to your social studies teacher. All right, so what is C prime here? Well, C prime, let's see, C prime of X is equal to, well, 2,000 is a constant. So then I got 100 minus 0.1 times 2, that's 0.2x. And it says I want the marginal cost when 100 machines are produced. So that means I'm plugging in 100. So C prime of 100 is equal to 100 minus 0.2 times 100. That's 100 minus 20, that's 80. So the marginal cost is $80 per machine. Okay. Excuse me. Part C says, show that marginal cost when 100 washing machines are produced is approximately the cost of producing one more washing machine after the first 100 have been made, by calculating the latter cost directly. Oh, okay, so it's asking us to find the cost of making that 101 washing machine. Okay, so then what you're supposed to do by interpreting this problem is figuring out the cost of 101 minus the cost of 100, because then it'll give you the cost of the 101st machine. So that one extra one, that one more after 100. So you can't just calculate the cost of 101. That's producing 101 machines. I want the cost of that 101st machine, that one more machine after producing 100, right? So you take the cost of 101 minus the cost of 100, you'll get whatever left over is, that's the cost to make that extra one after 100. Okay, I hope that made a lot of sense. So let's see, the cost of 101 is 2,000 plus 100 times 101 minus 0.1 times 101 squared. All right, yes, you could use a calculator for this. I really don't expect you to do this part by hand. But again, try to refrain from like graphing calculator, just because you really want to get the hang of not, right? So that's 2,000 plus 100 times 101. So that's 10,100 minus 101 squared times 0.1. That's 1,020.1. Okay. So then I take that and add up to the 10,100, add that to the 2,000. One more time. Sorry, my calculator's not giving me the right answer, so let me try again. 101 times 0.1, just making sure I got all the numbers correctly. Okay, so I add 10, I add 2,000. All right. So the cost of that is $11,079.90. Okay, and I take $11,079.90 minus my cost of 100, so 11,000. So the cost of making that next one is $79.90. And again, that should be really close to my marginal cost there. They're off by about 10 cents, so not too bad. Okay, all right. Last but not least, this is where it gets a little more interesting. You have to figure out how to interpret the problem. The problem saying a body's velocity at t seconds is this function. So I have the velocity function. Find the body's speed each time the acceleration is 0. Okay, so you got to find out the relationship between acceleration and velocity. And I believe in the front of our notes, we did mention that really quickly when we started the notes. So reminding yourself that, hey, velocity or acceleration, a of t is equal to v prime of t, right? So you got to take the derivative of v first. So v prime of t is now 2 times 3, that's 6t squared, minus 9 times 2, that's 18t, plus 12, and then that 5, this is meters per second, this is a unit, so it's not a variable, right? So each time the acceleration is 0, so this is acceleration, right? And right now I'm saying I'm setting that acceleration equal to 0. So when is acceleration 0? When? You're solving for the time that this happens. So 6t squared minus 18t plus 12, when is this equal to 0? Well, let's see. Let's use algebra then. Can we factor? Yes, we can factor out 6. So 6 times t squared minus 3t plus 2 equals 0. Divide by 6 on both sides, so you get t squared minus 3t plus 2 equals 0. Now let's factor. This factors into t minus 2, t minus 1 equals 0. So at t equals 1 second and 2 seconds. So acceleration will be 0 at those 2 points, right? At t equals 1 and t equals 2. But am I asking for the time? Am I asking for the time? No, I'm asking for the speed, the body speed each time that equals 0. So the body speed at these times. So my first step is then to find the velocity at those times. So v of 1 is going to be 2 times 1 cubed minus 9 times 9 times 1 squared plus 12 times 1 minus 5. That gives me 2 minus 9 plus 12 minus 5. Okay, that gives me 0. 0 meters per second. That's the speed, right? It's not moving at all. Okay, that's fine. How about v of 2? At 2 seconds, what am I going to get? So I get 2 times 2 cubed minus 9 times 2 squared plus 12 times 2 minus 5. So that gives me 2 times 8 is 16 minus 4 times 9 is 36 plus 24 minus 5. So that gives me I got 30, 40 minus 41 is negative 1 meters per second. Okay, so again, this is the velocity at those 2 points. So you get 0 meters per second and you get negative 1 meters per second, but this is velocity. So lastly, to answer the question, the speed is 0 meters per second at t equals 1 second, and 1 meter, because of speed, is going to be the absolute value of this answer, right? So 1 meters per second at t equals 2 seconds when acceleration is 0. Okay. All right, so that's it for this problem, and that's it for 3.4. Again, if you have questions, feel free to email or come to office hours if you want to ask some questions. Okay? All right, that's it.